couple more registrations coming through, but I think we'll make a start. No one's joined since I've explained last, but as I said, my name's Rick Nord. I'm Global Technologies Manager here at Nexus. Engineering and trade background, and really my focus at the moment within Nexus is early engagement with key clients. We have Nick Trevean as well. He will be sharing a presentation today on one of the wireless crawlers that Nexus has. As I said, a couple of ways to ask questions. Just ask away, Q&A in the chat feature on the bottom of your screen. The presentation is about an hour, and we'll run through an introduction into Nexus. I'll introduce Nick, and then he will share his thoughts and experience as well on the wireless crawler that Nexus has. You can go to the next slide, please, Nick. Thanks, mate. So just an introduction into Nexus. Been around since about 2014, and the key for us is really around the end-to-end solution, being a one-stop shop when it comes to robotics, NDT, some of the manufacturing side of things as well, cleaning, and then also the maintenance side. There's a big focus on the engineering, and it's bringing it all together to focus on global technology for field applications. And everything we talk about today is, I guess, one of those examples about how we cross-collaborate and we partner with not only our own sister companies, but also industry partners. So as I said, started in 2014, about 40 plus people at the moment, and really started as a rental business, and that's still one of our main revenue streams is the rental business. It is also expanded into custom development, which we would take an onshore application that a customer would share with us from the start. We'll look at the problem. There might not be a solution available on the market, and we would do a custom development for that project. And we take it through. We start at the beginning, share what the problem is, and we take the customer through. We would actually go to site if it's a new technology, and then we would partner with the client, share our thoughts when it was successful, and then look at some learnings as well if it wasn't as successful as we'd like it to be. A couple of offices at the moment. So there's one in Australia, which is the headquarters. There's also an office in Singapore and an office in Houston. And each one of these offices have their own equipment, and we share equipment all along the way. But we're really trying to operate with our boundaries and without borders. So we communicate with our Houston office on a daily basis, same with the Singapore and Australia offices as well. So there are these global reach points we can, depending on where I see some international names I recognise as well from people we've dealt with previously. So there's a couple of different offices you can deal with as well through that. As I said, a couple of different revenue streams. So the rental market is still a big revenue stream, but then the custom engineering. So there's two sister companies within Nexus as well, which is the 6D, which is a custom engineering. It's a full manufacturing workshop for CNCs, lathes. There's some EDM capability as well, welding and manufacturing capability here in Australia. So we work very closely with them to implement those custom robotics where there isn't something available off the shelf. Where Nexus comes in, so it's the rental market, get a crawler off the shelf, get drones off the shelf, and we can rent those out. There's some long-term leasing options as well through the Nexus streams. And then the last option is the training one. So we have new robotics in a market where it's quite a difficult place to work in, onshore, offshore mine sites, oil and gas. And we train service providers, we train operators on how to use this technology correctly, how to deploy them correctly, how to implement them correctly, but also how to retrieve all the robots safely as well, so we don't get crawlers stuck along the way. And that's really where Lab 61 comes in. So we run a program that we do through that as well. Three different ways, I guess. So there's the NDT side. I've spoken about the RBI, and then our focus is the Gen 2 robotics. So one of the ones that Nick's talking about today falls part of that. And then implementing, I spoke about the end-to-end solution. So that's really where we try and engage with the client at a very, very early stage. We've seen great success the earlier we engage with a client, rather than just, I guess, getting the end story. We take the journey with the client all along the way, and we make sure we develop it successfully. And everyone is involved in the process, and everyone has some buy-in as well. Do you want to spin to the next slide, please, Nick? All right, so I'd like to introduce my long-term friend and also colleague, Nick Trevean. He's the technology projects lead here at Nexus. Comes from an engineering background, NDT background, 3D services, and also digital technologies background. He spent the last 10 plus years honing his engineering and leadership skills, not just in the office, but also in a workshop environment, hands-on. He's been onshore, he's been offshore, locally here in Australia, but also internationally. Nick's personally been involved in designing, he's been involved in the manufacturing, the testing, but also successfully implementing custom robotics that are still being used in the field to this day. Engineering and digital technologies guru, and with his focus on technology is trying to expand the Nexus capability to expand your business as well. Did you want to take that away, Nick?
Yeah, thank you. That was probably a better introduction that I could do myself. But yeah, thank you. Yeah, so as Rick was explaining, I'm the technology project lead at Nexus, and I guess what that lets me do, which I quite enjoy, is sort of look at new technologies in the field and on the market, and how we can sort of bring that into our fleet. And one of those technologies is what I'll be talking about today, which is the SAIR wireless crawler. So just a bit of an agenda of what I've sort of broken this down into. I kind of figured a good starting point is to explain what is SAIR. And then just for interest, it's got a pretty interesting development history. So I sort of run through how it came to be and formed into what it is now. And then look at the principal operation of the unit and sort of go through some of the unique features it's got. And then look at some field applications and then sort of open up for discussion at the end there. And as Rick was saying, any questions along the way, feel free just to throw them in and we can just touch on them as we go through. So SAIR's Saudi Aramco inspection robot. It's essentially a wireless crawler capable of performing ultrasonic and visual inspection. And it was developed in Saudi Aramco, and it's been tested and piloted in several of their facilities. So it went through quite a development through that process of field testing. And then a company called Arabian Robotics Company, which is a joint venture with Saudi Aramco, it was established specifically to be able to provide non-destructive testing services into the oil and gas industry and kind of be an avenue to feed in robotic solutions. So Arabian Robotics Company, ARC, is who we've sort of been partnering with to bring this product in. And yeah, they've been quite good at sort of bringing this along the way. And I guess the objective for Nexus is to be able to take a technology like this, analyze it, work out where it's going to work best for our customers, and then sort of build a knowledge base around it so we can make sure it's used in the field correctly, that we can provide training for it. And yeah, basically just get it running in the field as it's been intended. Yeah. So hopefully the video plays through nicely, but this kind of summarizes nicely the idea of SAIR. So it's a wireless magnetic crawler robot. And as I was sort of saying, it's capable of doing RVI inspection with a camera, and then UT thickness inspection with a probe that's mounted underneath. Its sort of unique feature is that it's wireless in nature, which is pretty different to most of the other crawlers we've had in the past, which will have a tether for data and communications. This has everything running on board, which is quite unique. And then the other draw card that really drew our attention to it was the wheel mechanism on the front that has this unique sort of design that lets you be able to transition over curved surfaces without getting sort of jammed up, which I'll sort of touch on when we start looking at the wheel assembly.
I think that video played well, mate. Just, I guess, for the audience, depending on your internet connection, that might not play well. We also have a YouTube page, just Nexus YouTube, if you do want to go and find it there. Or if you go to our Nexus website as well, the video and all the information is there as well that would help you. But that played well on my side, mate. Yeah,
hopefully it streams through for everyone else. The video sort of helps convey the maneuverability of the unit that a picture just can't really do, I suppose. But yeah, as Rick was saying, available on YouTube under our channel. Yeah, so in terms of development of the unit, it sort of started off as a bit of an R&D project with Saudi Aramco at a university, and went through quite a few revisions there. And I kind of like projects that get to go through that sort of inception, because before the finished product sort of delivered, it's gone through quite a few, I guess, rebirths. So we can sort of see in the image here, there's SAIR 1, SAIR 2, SAIR 3, SAIR 4. And sort of running across, you can sort of see it. The unique feature of SAIR is really the wheels, and say in SAIR 2, the back wheel there is an omnidirectional wheel, which makes it have a really interesting way of steering, and that concept of the wheel sort of carried through from SAIR 2 to what we've got now, which is SAIR 4. But interestingly, there was kind of quite a few ideas explored with the camera and the UT probe underneath, and later on adding a gas monitor, which was quite a good addition. So over its development, it ended up sort of collecting approximately 10 patents that relate to various parts of the crawler, mainly around the wheels and the sort of innovative design. And then in late 2016 is where it kind of kicked off as a commercialization agreement with ARC. So sort of running through the principal operation, I sort of broke it down just into its core components. So we'll sort of look at its wireless ability, the wheel design, and then how it performs in inspection. So the camera on the front, the UT probe underneath, and then the gas monitor that's mounted on the rear. So wireless operation, it's a pretty interesting one to bring on site. The unit runs off a wireless interface between the tablet and the crawler itself, and it has a range of up to 100 meters. And to achieve that, it uses a wireless booster. There's approximately 2 hours of battery life on the unit, and the tablet controller itself is a pretty nice touchscreen interface that sort of gives you the visual inspection as the camera feed. UT is the A scan and B scan. And then mainly for pipe inspection, but it's also used for vessel. But in terms of reporting, there's quite a nice interface for logging UT data down a pipe and then circumferentially around a pipe, which is quite good. So it kind of collects all those spots and strip scans for you in a nice sequence that then makes it quite easy to do reporting.
Nick, just a quick question that's just come through. You're saying 100 meters. Can you explain a little bit what frequency that would run on?
Yeah, that's a good point actually, which is sometimes a concern on some sites. So it's a 2.4 gigahertz wireless frequency that it runs off. And it uses, if we're in short range, the wireless from the tablet itself is pretty good for running the crawler. So in the field testing, we've found in the realm of say 10 meters away from the crawler, the tablet itself can establish that link pretty reliably. But if you do then need to actually go a reasonable distance with it, there's a TP-Link directional antenna. So that's sort of set up on a tripod or elevated, so it can maintain a good sort of connection to the crawler. And with that antenna, you can get that extra range.
Well, mate, couple of extra questions. I'll ask the first one, I guess, and we can expand on that a little bit. Being magnetic wheels, it won't work on non-ferro acids?
Correct, yes.
Okay. I guess just, thanks for the question. One of the things to expand on this is maybe one of, I think, about 30 different crawlers that we do have. So there are other options that are tethered that do have the options to go on non-magnetic acids. So although this one can't necessarily, there are other options available within the Nexus fleet that can cover non-ferrous acids. But that's a really good question as well. Thank you. One last one as well, Nick. Complex acids. So I guess you're going to show a video a little bit later on, but maybe we can preempt that a little bit. Complex acids, so something like a cargo tank on an FPSO, has some I-beams, has some obstructions. Is this something, assuming it's ferromagnetic, is this something that can be used in there?
Yeah, so I guess that it holds some of the limitations that we traditionally have with most of the magnetic crawlers. It can navigate over welds quite comfortably, but I guess transitioning 90-degree interfaces, it's not really designed for. But I suppose the answer for that would be that with correct planning, you can maybe deploy this in a sequence that sort of favors how it couples onto the surface.
Yeah, good point. Thanks, mate. Yeah, I guess just the early engagement side of it, making sure we get scan plans right, making sure we know how to deploy, but also how to retrieve. I think you hit the nail on the head there. That's good.
Yeah.
There's a couple more, mate, I think, but let's go to the next slide, or your current slide, and we'll answer some of these others coming up.
Yeah, no worries. Yeah, just I guess we can bring those up as they reach their slide as well. Yeah, so sort of touching on the wheel. So the image I've got on the screen is the underside of the crawler, and you can sort of see it doesn't really look like most other systems. So it's got this curved wheel on the front, and then this omnidirectional wheel on the back. So as I was sort of touching on before, the wheels give it this interesting way of steering. So when the vehicle's moving, the front wheel provides the drive, which is the smooth wheel on the left. And then when you go to steer, you sort of kick the back end out of the unit and start moving the tail to move in the direction that you want. So the back wheel rotates. The main wheel on the back rotates to do the steering, but when you need to go forwards, sort of the small little roller wheels on the front ensure that wheel doesn't drag. Not sure if that's a good way of explaining it, but you'll probably see in the video a bit more easily how that operates. So it's, yeah, quite a unique way of doing it. And the front wheel in particular, it has this curved design, so it has these two sort of points of contact. So you can end up running down a pipe and then be able to rotate and then start going around the pipe as well, which I'll show you in a video now, which is quite interesting. And then just to note, as a sort of spec sheet thing, it can run at 140 mil per second.
Not sure if you're going to cover this shortly, Nick, but things around rust. It's just
yeah.
Maybe you just want to cover that. The question is based around carbon steel, obviously. How does rust affect the wheels?
Yeah, sure. Yeah, I'll quickly explain this video. So I guess part of what we want to do with the unit is do a bit of a stress test, because it's always nicer to figure these things out before it goes out in the field. So hopefully the video is playing nicely for you, but this was us running it over a weld on that pipe and just trying to find a configuration where it might not be able to overcome the weld, or it might lose contact with the pipe. So we sort of initially tried a couple of straight runs across it, which was pretty easy. So you can sort of see there, the wheels quite comfortably go over that cap. And then started getting a bit more gutsy and said, oh, let's try and do it upside down on a curve, running across the weld. And yeah, it performed really well. I was really happy with how this worked. And it kind of shows the crawlers just really effortless and being able to run along the pipe, around the pipe, whatever sort of configuration you want. So touching on, Rick, the question was about rust, wasn't it?
Yes, I guess mainly around how does it affect the wheels?
Yeah, sure. So I've done a few tests with this, and it kind of, again, has a similar limitation to most magnetic systems that at some point you end up, the filings and whatnot that pick up off rust on the pipe build up on the wheel. And at some point that does end up locking up the wheel. Much like the other crawlers we have, you have to then take it off and clean it. But what we found here is the front wheel doesn't really suffer too much. It's more the back wheel will start to need a bit of cleaning and maintenance. But for the most part, we've tried it on quite a few different assets and vessels. Unless it's on a really degraded pipe, it's not really too much of an issue that we've found. And particularly on something relatively clean, it works really effortlessly.
A couple of other questions, mate, that would be good for this slide. Thickness of carbon steel. Have you had to play with a minimum thickness that this would adhere to?
Yeah, so we've tried it on, we've done a few tests in the workshop just on plate, just to see what the pull force is. And we've sort of found, we've still got a bit more testing to do on that one, but anything above 5 mil, it seems pretty comfortable with. We tried a couple of thinner bits of plate, and it became a bit of a challenge to sort of adhere to that and be able to steer at the same time. But yeah, it's something we're still having a look at. And I guess the other part of that we're looking at is coating thickness. So I've tried a few different assets with paint and whatnot on it, which hasn't seemed to be a massive issue. Obviously, it won't really work on something with a thick insulation or something like that. But yeah, for the most part, it seems to be pretty much on par with most of our other magnetic crawlers in terms of pull strength, which is good.
Thanks, Nick. The next question was actually coating thickness, mate, so perfect.
Cool, okay.
Are we going to talk about the battery side of things later with some EX, or should I face that now?
I'll pick that up now, I suppose.
Okay, so I guess the question is, being battery powered, how does it work around the ATEX, Zone 1, Zone 2? Do we need a hot work permit? How do we get around that?
Sure, yeah. So it does require a hot work permit. So it's in the same class as our other systems that run on 24-48 volts DC system. In terms of the battery, it's a standard, I think lithium phosphate battery, rechargeable battery, which we've found compared to the normal lithium ions, in terms of MSDS, it's quite a bit easier to deal with, which is good. But I guess circling back to the question, the unit itself doesn't have any ATEX or EX rating at the moment.
Well, that's all the questions for now. I guess just one of the things with the EX and IS, one of we try and really work with operators on, is it really required? Are there other options that we're looking at instead? What is the Zone 0? What is the Zone 1? Can we move the Critical equipment outside of that, then the equipment that goes inside the asset, are there an opportunity to purge, other opportunity to look at when to turn the equipment on, so it isn't a concern. One of the other things we do, so there's gas monitoring, and I think you're talking about that a bit later on anyway, but there are some options. The very first thing, I guess, for us is, can we look at avoiding having to need that EX and IS and even ATEX, I guess, in that case. Just as a side topic, there are also EX certified equipment within Nexus, just depending on the application. So there are some options available as well. And then we're also working on getting a crawler certified within our business this year as well. So there are some options as well.
Yeah, so I guess sort of touch on why you need to get the crawler up into a difficult space or on the vessel for inspection. You know, the first part of most inspections is an RVI, a bit of a visual inspection. So on the front of SAIR, there's a reasonably easy to use 13 megapixel camera with built-in LED lighting. And it's able to pan and tilt around, so it's able to pretty much look above and around for navigation purposes, and then the camera is able to pivot right down into that curved wheel, so it can get a close look at the surface underneath it, which is quite handy when you sort of set up to do a UT strip scan inspection, like a B scan. You can end up pointing that camera downwards, start the UT inspection, and then collect a visual record and a UT record of the area as you're running forwards. And then I just got the image there of the tablet interface. So there's the camera feed in the center there, and some sliders to change the LED lighting, and then the touch joy controls in the bottom corners to manipulate the camera and the steering.
A couple of extra really good questions that's just coming through now, Nick. It's just most around the physical aspects of the crawler. So length, height, width. What's the clearance that you need to pass through? I guess maybe if you explain a couple of things on length, height, and width. Yeah,
so I guess taking it in those core dimensions, 325 long, 180 width, and I guess the critical one for most inspections is the height, so 215 mils high. So within those bounds, that's sort of what it can navigate around, which I guess is a key one. And a key application for this would be pipe racking. So you'd want to be able to ideally sort of clip onto a pipe from a comfortable area where you don't need to set up scaffolding, and then start going up and along that piping into the inaccessible areas. So I guess the test restriction there is that height limit on any supports or anything that might be in the way there. I guess the nice thing, and part of the core design really of it being wireless, is when there is an obstruction like that, it's quite an easy unit to maneuver around the pipe to then find an area where there is clearance and then continue down the pipe. I'll touch on the UT probe. So that's the other inspection that is sort of deployed using SAIR. And again, a really nice innovative way that it's been implemented. So there's a dry couple wheel probe that's mounted on the belly of the crawler, and you can sort of see on the right image there, that's where it deploys from, and it's got a small sort of scissor mechanism with spring loading that lets you deploy and retract the probe. And then the other really nice thing is it's a dry couple wheel probe. So you don't have to get a water feed down there, which would be kind of difficult with SAIR. And we don't need to have an onboard reservoir of water feeding through. So the probe itself, 4 to 40 mil thickness, and then in the inspection software, it can either record spot readings, or it can do a B scan. So the nice thing that's been set up on this crawler with the B scan is that when you deploy the probe down, you then sort of look at your A scan, set up the gates where you want them, and then start recording. And a typical issue with a wheel probe is that if you accidentally run it across the wheel, you end up getting flats. So built into the software, which I thought was really nice, is once that wheel probe's deployed down onto the surface, it locks the steering. So the typical application for that would be on some pipe work. You deploy the probe down, either run down the pipe and collect your B scan, or steer SAIR 90 degrees and then do a B scan around the pipe.
Just there's two parts, I guess, to this one, Nick. Might be worth just explaining firstly what you mean with spot and B scan.
Yeah.
And then a flow on from that one. I'll ask that one after you've explained.
Yeah, sure. So spot reading would be to move the SAIR crawler into a position where you want to take a thickness reading, deploy the probe, and then take a reading. And there's some functionality in there, so you can take several readings off a single location and take the average of that as your final result. In contrast to that spot reading, the alternative, which is quite useful, is to take continuous readings as you're driving forward. And that's what we sort of call a strip scan or a B scan. So that's typically where you'd set it up on some pipe work or on a vessel, and then start driving forward and collect readings every, say, 1 millimeter, and collect that into a strip reading of thickness.
Thanks. The follow on from that, so this would have been someone, I'm guessing, that's used crawlers in the past doing a B scan where they've had damage to the probe or the housing because it's constantly dragging that probe. Are there any, I guess, modifications to this one, or anything that's different to this that stops you from ripping up that UT probe?
Yeah, so I guess you can't quite see it in the image here, but on the underside of the wheel probe, it's got a small brush that sort of removes any dirt or grime that's collecting on the wheel. So that sort of helps us keep the probe itself clean. And then the other one is in the software, as I was sort of touching on before. Once the probe's deployed, the ability to steer, it's not actually completely inhibited. It lets you do a very small amount of steering, but it ensures that when you drive the crawler with the probe deployed, it'll only drive in a way that sort of supports the motion of that wheel probe. It won't let you accidentally drag it across the surface and put a flat spot on it.
With that in mind, there's another question that came through. It's regarding to the B scan. Let's use a pipe as an example.
Yep.
Can you do a longitudinal and a circumferential scan just by rotating the crawler?
Yeah, 100%. And that's one of the main appeals of the unit. So the idea might be that you deploy on some pipe work, deploy the UT probe down onto the surface, and then start taking B scan readings as you're running along the pipe. And then you might want to incrementally down that pipe want to stop, retract the probe, rotate the whole crawler 90 degrees, and then deploy the probe again to start doing a B scan around the pipe. So you end up being able to do thickness readings down the whole length of the pipe, and then at periodic sections that I guess tie in with the inspection criteria, rotate the crawler and then do some B scans that do rings around the pipe work. Okay, and then the other innovative sort of device that got implemented in SAIR 4 was the addition of a gas monitor. So it's mounted on the rear and does readings for methane, carbon dioxide, and oxygen. At present, it's presented as a percentage on the graphic user interface on the tablet. And it's essentially there just as a monitor for the operator at the moment. So one of the thoughts that we had when we were testing the unit was it might be an interesting idea if the crawler could shut down at a certain threshold of detecting, say, methane or something like that. But at the moment, it's more an observation tool that's mounted on the back there. So in terms of applications, it really comes down to SAIR's being developed to inspect, I guess, elevated pipework areas that are hard to access or might have been inconvenient and needed scaffolding. And then I guess the other side of that would be vessel inspection as well. So again, areas that are sort of traditionally a bit difficult to access, if we can avoid scaffolding to take some periodic UT readings on the far side of the vessel, it can be quite a cost-effective operation. So in terms of vessel inspection, as we've sort of touched on, we've got the camera for RVI, UT spot readings and strip scans. And one of the really nice things we tried out in the workshop was dome end inspection on vessels, which has always been quite difficult to do. It's usually quite annoying to map out a dome end to do spot readings manually. A lot of the crawlers don't deal well with the curvature. But what we found was SAIR's really good on dome ends. So the application would sort of see there is to set up SAIR to do strip scans across a dome end and sort of just keep doing strips across until we've sort of done an asterisk configuration, I suppose. And it'll give, yeah, a really nice coverage, and it's fairly easy to deploy with the wheel probe, which is, yeah, quite good. In terms of piping, the smallest it'll operate on is 8-inch, and that's purely a function of the wheel design. It can go smaller if the wheels are brought in closer, but the chassis as it stands at the moment sort of been optimized for 8-inch all the way to flat. And as we're sort of touching on before, piping, again, really good for remote visual inspection. And then in particular, with the reporting functionality that's built into it, being able to do UT strip scans down a pipe and then periodically rotating 90 degrees to then do some ring scans as well works really well.
Just a couple of quick questions, Nick. And it's a bit of a flow on from some of the other stuff. At the moment, this has UT built into it.
Yep.
Can we add other NDT methods to it? This question is based specifically on coating thicknesses, but why don't we put some other systems in there as well?
Yeah, absolutely. I guess part of this webinar for me is to show everybody this really nice crawler that we've got, and sort of try and get some feedback on what other applications we could see for it. So it's absolutely, yeah, taking thickness of coatings is something we'd definitely want to apply to this.
And something we've done in the past as well, so taking off-the-shelf crawlers and then integrating not only their own systems onto it, but some other partners and technology partners into that as well. So putting different technologies, so be it ultrasonics, so be it if it's DFT for coating thicknesses, but also the pulsed eddy current side of different manufacturers, different technology providers, integrating all that into the crawlers. And then we've also built some custom tooling that incorporates a multitude of these. So it doesn't just need to be one system. It could be UT with the coating thickness as well. So there's definitely some options, just depending on what the application is. I guess for interest, Nick, there's a DFT inquiry, and then there's also pulse steady current, I guess, for some of the assets that have a thin coating that UT might not work. Someone's asking about pulse steady current integration as well.
Yeah, absolutely. Yeah.
We briefly spoke, I think it was about slide 4 or 5. You don't have to go back, but there's a question around weld seams, and I guess it comes back to the vessel inspection as well. Have we tested maximum weld seams that we can cover?
Testing at the moment, sort of been a process of using the test vessels we've got in the workshop, and trying to find the most challenging weld configurations we can to sort of drive over them.
Have we tested the weld seam that was at 12 o'clock that we've used previously for factory acceptance tests?
Have
we tested that?
Yeah. I'm just trying to think what we call that. So,
maybe share the dimensions on that one, because that's, I think, quite an extreme weld.
Yeah, I can't remember the dimensions off the top of my head, but I remember when we were asking the guys at 6D to put that weld in the. We kind of wanted on this test piece to put a weld on the, I guess, the 12 o'clock position, but it's from the inside. So it's essentially a scenario where the crawler's upside down, having to navigate over a weld. And I think initially we were sort of saying to them, I think a good figure would be 3-4 mil penetration. But in the end, it turned into a really fat weld. I'd have to sort of check the measurement on that. I don't know if you remember what it was, Rick.
I'm just looking at the drawing. So 20 wide as a cap width,
yeah,
and the actual cap was 10 mil. So 20 wide and a cap of 10 mil.
Yeah, which was pretty extreme.
And just like one thing that you mentioned, though, there was that at 12 o'clock. So the most difficult location for a crawler, and a very extreme weld as well. So things like lap joints and standard welding is okay.
Yeah. I guess I didn't really touch on it before, but the wheel design, there was quite a lot of time invested in that during its development. So the front wheel with the curved inside, there's quite a bit of time spent on trying to find the best way to get that magnetic field to sort of flow through and focus on the ends of the wheel. And the other really nice thing during testing, and particularly when I've gone out to test this at clients' workshops and sites and whatnot for demonstrations, is that the front wheel that does the majority of the actual driving has rubber lining on it, which some other magnetic coupled crawlers kind of avoid, because it essentially creates lift off on the magnets. But the nice thing with SAIR is it's sort of maintains good contact through that wheel, but with the benefit of the rubber lining, it doesn't leave tracks behind. It doesn't rip up any of the coating on the asset, which is makes it much easier to use on site.
A couple of good more questions, Nick, but I think go to the next slide and we'll keep running through.
Sure. So this is another test we're doing. So this was on some pipe work, and sort of looked at, like, an elbow usually is like a pretty tricky geometry to be able to drive on. And we can sort of see this weld was a bit of a challenge initially for that omnidirectional wheel. But with the right alignment, we end up getting over it quite easily. And then, this sort of shows the ability for it to quite comfortably go up the pipe, around the pipe. And it's not really even that it needs to go straight down the pipe or directly 90 degrees around it. It's pretty comfortable just doing sort of a helix path, or just sort of freestyling around the pipe, I suppose. And then this was the point where I was sort of using the camera to look at a few bits on the pipe, sort of show its functionality there. I think it just goes out of frame. But in a minute, it'll sort of drive down again, and we can sort of see it. There we go. That's better. So hopefully the video is coming through okay for everybody, but looking at like an application like this, to be able to get access to that sort of height of pipe work on site to do visual or UT thickness, it usually ends up involving scaffolding or some kind of elevated platform. And being able to, I guess the challenge there is a lot of the time that kind of almost rules out some inspections or at least reduces their frequency. So we sort of see SAIR being quite a nice option for being able to increase the frequency of those inspections, and particularly pipe work, pipe racking. It's something that gets sort of forgotten quite a bit, or there'll be a bit of a visual done on the underside of it where it's kind of easy to do, but then there ends up being a few surprises on the top where no one's really looked for a couple of years. We sort of see SAIR being a pretty good option to sort of do runs across the top of those. And again, you can sort of see in the elbow there, initially I crept up the side of it, and then on the return, I just went directly down through the intrados. And this is just another one we've got. This was the dome end, so this was just a bit of testing, just to see how it'd go with the welds on the dome to the rest of the body, and then just sort of seeing how it goes with the way that the curvature sort of blends in and out as you're going across the dome end. And yeah, it performed really well. I was really happy with it.
Do you remember the approximate diameter for that one, Nick?
I don't. I'd have to
Couple of meters?
Yeah, at least, yeah. Brilliant. So that's my sort of rundown of SAIR, a new bit of technology that the Nexus is introducing to our fleet. As a summary, its main appeal is for RVI and UT thickness inspection, magnetic coupled wheels, so carbon steel applications, wireless connectivity, so 2-hour runtime off the batteries, 100-meter range using the booster, gas monitor on board, and the key applications being vessels, internal and external, and then pipe work externally. Brilliant. I'll open up to any extra questions now, Rick, if you've got them.
Yeah, it's an interesting one. If you mind going to the previous slide, I guess they're asking about trickery in the video. Was that done at full speed?
Yes.
Excellent, mate. No, there's just the question comes through that it seems to run very, very fast, I guess, compared to other crawlers. They were just asking, was the video sped up or not?
Yeah, I mean, Colin's my little check there as he walked past. He didn't seem to accelerate past.
That's good, mate. It's a good question. I enjoyed that one.
Yeah. Yeah, I guess it is pretty zippy compared to some of the other crawlers we've got.
Another question, and I guess I'll open this one up a little bit around environmental ratings. So things like dust, things like water. Does it have a rating? And then knowing the answer, I guess, can you talk about maybe some of the other options that we can do with like a splash zone or where there is water?
Yeah, okay. So the current version we've got at the moment, it doesn't strictly have an IP rating approved for it. In terms of, I guess, the design of it, everything has gaskets, seals. The connectors are splash proof. I wouldn't say it's at the point where it's subsea rated, so we can't dunk it underwater yet. I guess I was trying to think who was saying it, but it's subsea rated once, and then after that it's out of operation. So in terms of the camera and lighting, they're all gasketed and sealed, so they can take a bit of splash and a bit of dust and things like that. But we can't submerge crawl SAR just yet.
Yeah, I guess expanding on that, there are, and I've said this a couple of times, there are other crawlers in the fleet as well. So there are probably about 16 or 17 different crawlers that are specifically made for things like jetty piles in that splash zone, rated to quite deep distances or lengths for pipe work. So there are other options available depending on what technology you want to implement in terms of NDT, or do you want to do maintenance. So there are a couple of other options available as well. That's a good question, thanks.
Yeah.
There's another one around coating, and I guess we talked about the coating thicknesses. This one's more based around the UT. So let's assume we can stick to the material. Can it travel through things like fiberglass or a composite material, the ultrasonic specifically?
Okay. Yeah, I guess that's sort of where would look at applying new technologies to SAIR and sort of treat SAIR as almost a delivery platform. So the dry coupled wheel probe, as far as I know, isn't really compatible for going through fiberglass coatings. But we've definitely got technologies that can go through those sort of coatings that we could apply to SAIR to fit that use case.
Perfect. Thanks, Nick. Appreciate that. There's a few more coming through. I guess just while running out of time, there's a couple of extra people leaving now. Just wanted to share we are doing webinars weekly. They're on our LinkedIn, on our Facebook, and then we send them out as well if you're on our client list. And they cover various topics. So there are some open topics as well that might cover 2 or 3 different technologies all in one presentation. But then we also do webinars specifically for clients. So we do about 1 or 2 client-specific webinars. And it's essentially what you want to talk about. So if you have a specific problem, if you have a specific technology you want to talk about, then we're happy to run through those as well. And we do face-to-face as well if you're in Australia, Singapore, or Houston. A few more questions. For those leaving, I appreciate your time. Thanks, Nick, as well. We'll answer a couple more questions for those hanging around. But I appreciate everyone else's time. Thank you. This is a good question. 2 parts, Nick. I saw in one of the videos how the tether. So is the tether needed? And then the second part is based on a fail-safe if the battery runs out.
Yeah, that's a good question. And when I was sort of researching and looking at SAIR, and I guess the concept of having a wireless crawler and the challenges that allows you to overcome, but also the challenges it brings in. So I'll answer, I guess, the failsafe first. On the interface, the battery level has a pretty clear indication of when you're at the halfway point. So when you get to that stage, you're encouraged, I guess, to backtrack and go to a spot where it can be taken off the asset and then have the battery swapped out. In terms of when the battery does run out, the wheels we found are geared in a way that won't let it roll down, which is sometimes a good thing to have. if you can have it set up in a spot where when the battery does die, it rolls down. But it sort of presents other challenges with loading on the motors and then decreasing the battery life. So we sort of found that in terms of operating it, we can operate it wirelessly, and that seems to work quite well in, I guess, low risk areas like a vessel, where if it is going to fall off the bottom of the vessel, it's got a fairly low area to fall from, and it's in a safe zone. But then something like pipe work, it's a bit more high risk, I suppose. So the idea there would be to attach a tether, and I guess that comes back to the recovery method, being able to use that tether to pull the crawler down if we need to, and then if the crawler for whatever reason loses contact with the asset, we use that tether to rescue it. Yeah.
That's perfect. Thanks, Nick. No other questions. Thanks for your time as well, mate. And thanks everyone else for your time as well. We'll see you next time.
Great. Thank you, everyone.